Well, good morning or afternoon or evening, whatever time it is you happen to be looking at this. What we're going to be covering today is acceleration. Um, Acceleration is the rate at which you change your velocity. So if we were to look at how you would change your velocity, well, velocity's got two components. It's got a magnitude, which is the speed, and the direction. So if either we change the speed or the direction, then we change velocity and therefore accelerate. How could we do that if we were in a car or on a motorcycle? Well, we could change our speed by speeding up. We could change our speed by slowing down, or we could change our velocity by changing the direction we were heading. So by turning or changing direction. So the would we consider? Do you think acceleration would be considered a vector? Do you think it would have a direction that you'd be accelerating? If you said yes, you are correct. Acceleration is a vector. It does have a direction. So going from 25 miles per hour to 55 miles per hour, would that be accelerating? Well, we're changing speed, so yes. Okay. Going from 55 miles per hour to 0 miles per hour, so coming to a stop, would that be accelerating? Yes, it would. Even though we're slowing down, we're still changing our velocity, so we are accelerating. What about making a turn? So going 55 miles per hour north and then turning and going 55 miles per hour east, would that be accelerating? Yes, it would because we're changing our velocity, therefore we're accelerating. The equation for acceleration is this. Remember what the bar means? A bar. Bar means average, and this is the equation for average acceleration. We're only going to have one type of acceleration. We're not going to have instantaneous acceleration or anything like that. So you don't really need to worry about the bar. Usually I'll leave it out, but I'm just showing you for to be explicit that is average velocity. So average velocity equals the change in velocity divided by the time. It is the rate at which you change your velocity. Okay, so yeah, we're always going to have a constant acceleration, so it's always going to be our average. We're not going to deal with changing acceleration. That we'll save for calculus, which Mr. Polokonis will teach you about jerk. So if we take this equation and plug in delta, if you remember delta x before meant x2 minus x1, delta V in this case also means final minus initial, or V2 minus V1. So here I've substituted in V2 minus V1 for delta V. And what we want to do is we want to solve this because very frequently we want to know what the final velocity is, V2. And so having solved this, we get V2 equals V1 plus AT. This is one of the equations that's on your equation sheet, although it probably is V equals V naught plus AT, the slightly different nomenclature. Which, if you have not found the equation sheet yet, it is a couple places. It's at the very top of the modules is an equation sheet, and also in this current module we're in. I forget exactly where it's at, but we'll make sure you find it. If I wanted to look at what we would measure acceleration in, or what the units would be, well, when we are dealing with velocities, we're going to be dealing with meters per second. That's always going to be our unit of velocity, is going to be meters per second. And then when we're dealing with time, that's always going to be with seconds. Okay. So this is known as a complex fraction, I believe. And what you normally want to do is get rid of the bottom, the denominator of the whole thing, by multiplying by its reciprocal, the top and bottom by its reciprocal. So what we're going to do is multiply both the top and bottom by 1 over s. What that's going to do is cancel out the s on bottom, okay, and that'll leave us with meters per second times 1 over seconds. The seconds are going to square, and you're going to end up with meters per second squared. What we've done here is just simplified it, but really what a meter per second squared stands for is a meters per second per second. And that's what acceleration is. It's the meters per second you change per second. So if we have a person who's V1, your initial velocity is 10 meters per second, and they accelerate at 4 meters per second squared, or 4 meters per second, okay, what's their velocity going to be after 1 second? Well, it's very simple. Okay, their velocity is going to change by positive 4 meters per second, okay, every second that elapses. And that's as simple as acceleration is. It's the meters per second that is changing per second. So let's see if I can use my drawing tools with this. Okay, now theoretically I'll be able to draw on this screen. We'll see how it works. So we've got a car is moving at 58 meters per second when it opens up its chute and comes to a stop 38 seconds later. What is the acceleration during this time? And again, it's talking about the average acceleration. We're only going to have average acceleration in this unit or this class. So let's see. A car is moving at 58 meters per second. So what we want to do is figure out which variable that is. Well, I guess first off, we figure out the equation that we're going to use. It's probably going to be the acceleration equals v2 minus v1 over t. Okay, so this 58 meters per second, that is going to be which v? Is that our v1 or our v2? Well, that's the velocity that it's moving at initially, so that's going to be our v1. It opens its chute and comes to a stop 38 seconds later. Well, that 38 seconds, that's going to be our time. If we're going to calculate the acceleration, then we need v2, v1, and t. Right now, I've only got v1, and t. I need v2. It does tell us v2, it's just not in the form of a number per se. It says that we come to a stop. So that tells us that whoa, I don't know what just happened. v2 equals 0. There we go. Whoop, now I deleted it. So what we'll do is we'll go ahead and plug in those numbers. We got v2 equals 0, v1 equals 58, and t, which is equal to 38 seconds. So we'll go ahead and do the algebra there. And we're going to get negative 1.5 meters per second squared. So that means that our velocity changed by negative 1.5 meters per second every second. And well, what does that negative mean? Well, remember when we dealt with displacement and velocity, the negative meant the direction. Okay, and it does mean the direction. It means really two things here. It means the fact that the velocity is going to change by minus 1.5 meters per second every second, and it also means that the acceleration is in the negative direction. Okay. So objects accelerate because of a force. Forces cause acceleration, and forces have a direction. That car was getting pushed opposite the way it was moving. It was getting pushed probably to the left since it was a negative. And so the direction of the acceleration is just the direction of the force that's causing it to change its velocity. So if we look at a car then and we stick it on a number line, so 1, 2, 3, 0, 1, 2, 3, and we say that the car is traveling down this way. So the sign on the velocity, would the velocity be positive or negative? Well, it's moving in increasing numbers, positive numbers, so that would be positive. Now, if we have positive acceleration, okay, if we have positive direction, sorry about that, had a phone call. So if we accelerate in the positive direction, so that means that we're going to be pushed in the positive direction. So if we're moving in the positive direction and we're being pushed in the positive direction, what's going to happen to our speed? Well, we're going to speed up. Okay, so positive velocity, positive acceleration causes the speed up. Now, if we accelerate in the negative direction, which means I'm moving to the right, sort of, and then I'm getting pushed to the left, okay, that's going to cause my velocity to decrease. So I'm going to slow down. So a positive velocity and a negative acceleration will cause me to slow down. What you're going to see is if the signs of the velocity and acceleration are the same, you speed up. If the signs are the same, you'll speed up. And if the signs are opposite, you'll slow down. So here we just get the car going the other direction here. So in this case, we've got the positive direction moving down and to the right. The car's velocity is going to be negative. Now, in this case, if we have positive acceleration, it's going to be opposite the way the car is going, okay? And therefore the car is going to slow down. So again, as I said, if the signs are opposite, velocity is negative, positive acceleration will cause it to slow. And if the signs are the same, then it'll speed up. Just as if we look at the negative acceleration. So here the car is traveling in the negative direction. It accelerates in the negative direction. It's going to be speeding up. Let's see. Okay, so here we've got just another simple example with the table. We've got an object that's moving in the positive direction initially. It's v1, its initial velocity, instantaneous velocity is plus 10, and then it's going to undergo a constant acceleration in the negative direction of minus 5 meters per second squared. So what we're going to see is after 10 seconds, its velocity is going to change by minus 5 meters per second each second. So it'll be moving at 5 meters per second. Then after 2 seconds, it'll slow down to 0. Okay? And then it'll change by -5 again, and then -5 again. So what happened to the car? So what it did is, at first, the car slowed down. Okay? It was moving forward in the positive direction because it had a positive velocity. It was moving forward and it slowed down and came to a stop. Then it continued to accelerate and started moving in the negative direction or backwards. Okay? And then it continued to speed up. So it slowed down, came to a stop, and then started moving backwards, speeding up is what the car did. So here's just another simple example. We've got a car initially moving at 5 meters per second. It accelerates at -2 meters per second for 6 seconds. What's its final velocity? Well, remember what happened if we solve this for V2. That's probably where we want to start first, is to solve it for V2. And V2 equals V1 plus AT. That's kind of an equation that you'll hopefully have memorized because you'll use it. And so what I want to do is try drawing on the screen again here. So we'll read the word problem, underline what it's given us, and then figure out what we're trying to find, as well as what equations are going to help us get us there. This is if there's a problem that I'm going to have to work at to solve, I'll use this method. I'll stop and I'll underline every bit of information that's important. So a car is initially moving at 5 meters per second. Okay, so that is our V1. That's our initial velocity. V1. Okay, it accelerates at a rate of -2 meters per second squared for 6 seconds. Okay, so that meters per second squared is the tip off of that is the acceleration, not necessarily just because it comes after the word accelerates, because words can be juxtaposed, but the fact that it's got the units on it is really what indicates it's the acceleration. So that is my A. That's my A. And then for 6 seconds, the units on seconds tell us that it's time. Okay. So what we'll do is, and what is the final velocity? So that tells us we're looking for V2 equals question mark. This doesn't work quite as well as I'd hoped, but it's better than nothing, I suppose. So we solved the equation, and then we're going to stick in the numbers. So V2 equals V1. V1 is our 5. The acceleration was -2, and the time was 6. So what we'll get is V2 is equal to -7 meters per second. What is the final velocity? So just another example. What if I gave you this problem? A car travels at a constant 35 meters per second for 7 seconds. What's its acceleration? Okay, you might be very tempted to take 35 and divide by 7 and see what you get. But if we do that, to find the acceleration, I need to know the initial, the final velocity, and the time. So a car travels at 35 meters per second. Which velocity is that? Is that my initial, my final, my average, or both, or all of the above? Okay. Well, the tip off here is the word constant. A constant 35 meters per second tells me that my velocity isn't changing. So the answer to this problem is just 0. It's moving at a constant velocity. On the top, I'd have 35 meters per second minus 35 meters per second, no matter what. So my answer is going to be 0. Okay. So a little bit of a review with displacement versus time graphs. And we want to consider the sign of the velocity and the acceleration here. So here we've got a displacement versus time graph. All right, and what we want to do is figure out, is it moving forwards or backwards? Well, it's moving backwards. If it's moving backwards, it tells us that our velocity is negative. So our velocity is negative. Oops, I guess so put a negative right here. And then the sign on the acceleration. Well, in order to look at the sign of the acceleration, we need to know what's happening to the velocity. What does the fact that it's a straight line tell us? The straight line tells us that the velocity is constant. It's not changing. So anytime you have a constant velocity, your acceleration is 0. So in this case, our velocity is negative and our acceleration is 0. we look at this scenario here, we're going to say, all right, what kind of motion is it? Am I moving forwards or backwards? Well, it's moving upwards with time, so that tells us we're moving forwards, which tells us that our velocity is positive. And then we want to figure out the sign of the acceleration. Well, what's happening to our velocity? Well, it's getting flatter and flatter, so that means we're slowing down. So if our velocity is positive and we're slowing down, the signs have got to be opposite for acceleration in order to slow down. So the sign on the acceleration is negative. So positive velocity and negative acceleration will cause you to move forward, slowing down. So what about here? So what is the sign on the velocity and what is the sign on the acceleration? So we're moving forwards, okay, which means the velocity is positive, and our acceleration, well, what's happening to our speed? The speed is getting steeper, the line is getting steeper, so therefore we're speeding up. So that tells us that we're speeding up, and therefore the signs of velocity and acceleration have got to be the same. So we have a positive velocity and a positive acceleration. What about the sign here? So what kind of motion? Well, what we're doing is we're moving backwards because the line is moving down with time. And then what's happening to our speed? Well, the speed is it's getting steeper and steeper, so it tells us that we're speeding up. So we're moving backwards and speeding up. Okay? The fact that we're moving backwards tells us that our velocity is negative, and the fact that we're speeding up tells us that our acceleration has to have the same sign, so it is also negative. I'm just skipping through a few slides here. Okay,